All right, welcome back to another video. I skipped the after work video yesterday. My life was just spiraling out of control. I was gaining weight. I was feeling bad. So I skipped the after work video and went and did some extra exercise. And I feel a lot better now. So let's continue with the topic of EVPNs. So I'm pushed back a day, but I'll go with the original plan, which was to just read through some of the basic documentation and then just move on. Unfortunately, there's really not much I can do for hands-on. I mean, I guess I can just try to set one up. They're not giving me information for how to do that, but I mean, it shouldn't be too impossible to figure out. Let's actually do that instead, because that could be more interesting. So I'm going to share my second screen, and just to make sure that this time isn't completely wasted, I think I will just read the overview to get a better, just to make sure that I did actually do something relating to EVPN, because I think if I just try and fail to configure it, that might not be as ideal. So here's all the EVPN standards. I'm sharing my second screen, I hope. So here's the common features. I'd like to find just an overview. Here's an overview for MPLS. I think that's, if it's going to show up on the exam at all, it's going to be for MPLS. So I'll just read this just to make sure I will have read something. And then I'll try to, for the rest of the video, just figure out how to set it up. This lunchtime video will go until like 1:15 or 16. I had kind of a late start to lunch today. An Ethernet VPN, EVPN, enables you to connect dispersed customer sites using a Layer 2 virtual bridge. As with other types of VPNs, an EVPN consists of customer edge CE devices, host router or switch, connected to provider edge PE routers. The PE routers can include an MPLS edge switch, MES, that acts at the edge of the MPLS infrastructure. Either an MX Series 5G universal routing platform or a standalone switch can be configured to act as an MES, MPLS edge switch. You can deploy multiple EVPNs, Ethernet virtual private networks, within a service provider network, each providing network connectivity to a customer while ensuring that the traffic sharing on that network remains private. Figure 1 illustrates a typical EVPN deployment. Traffic from data center 1 is transported over the service provider's network through MES1 to MES2, and then onto data center 2, DCS1, DCS2, DCS3, and DCS4 are the data center switches. The MES's multipath edge switches, I think, yeah, are interconnected within the service provider's network using label switched paths, LSPs. The MPLS infrastructure allows you to take advantage of the MPLS functionality provided by the Junos OS, including fast reroute, node and link protection, and standby secondary paths. For EVPNs, learning between MESs takes place in the control plane rather than in the data plane, as is the case with traditional network bridging. The control plane provides greater control over the learning process, allowing you to restrict which devices discover information about the network. You can also apply policies on the MESs, allowing you to carefully control how network information is distributed and processed. EVPNs utilize the BGP control plane infrastructure, providing greater scale and the ability to isolate groups of devices, hosts, servers, virtual machines, and so on from each other. The MESs attach an MPLS label to each MAC address learned from the CE devices. This label and MAC address combination is advertised to other MESs in the control plane. Control plane learning enables load balancing and improves convergence times in the event of certain types of network failures. The learning process between the MESs and the CE devices is completed using the method best suited to each CE device. Data plane learning, IEEE 802.1, LLDP 802.1AQ, and so on. The policy attributes of an EVPN are similar to an IP VPN, for example, layer 3 VPNs. Each EVPN routing instance requires that you configure a route distinguisher at one or more route targets, RTs. A CE device attaches to an EVPN routing instance on an MES through an Ethernet interface that might be configured for one or more VLANs. The following features are available for EVPNs: Ethernet connectivity between data centers spanning metropolitan area networks, MANs and WANs, one VLAN for each MAC VPN, automatic RDs, route distinguishers, dual-homed EVPN connection with active/standby multi-homing. The following Juniper Networks devices support active/active multi-homing, Ethernet EVPN, EVPN support, including MVPN-MPLS, MVPN, EVPN, plus VXLAN and PBB EVPN has been extended to logical systems running only on MX devices. The same EVPN options and performance that are available in the default EVPN instance are available in a logical system. Configure EVPN on a logical system after the edit logical systems, logical system name, routing instances, routing instance name, protocols, EVPN hierarchy. The following feature is not supported for EVPNs. EVPN MPLS features supported by QFX switches, so I'm going to skip that. So there we go. That's just to say that I did do something relating to VPNs. God damn it, I've got an MFI issue. It kind of took care of itself for a long time, but now it came back. Okay. That is really annoying. Okay. Okay, so let's continue on. The goal is to try to just convert this from a layer 3 VPN to a layer 2 VPN and be able to ping end to end. So we're going to be stripping away all of the unnecessary configurations, such as the multicast. Okay, so root, clouds, CLI, show configuration, put display set, put no more. So we're going to be taking a look here. If there's anything that's unnecessary, we're going to be stripping it. So let's strip protocols ping, or PIM rather. Okay, because we won't need that because that's specific to multicast, which we're not going to be doing. We're just going to be learning about how to use a different kind of VPN. In this case, it will be a EVPN instead of a layer 3 VRF VPN. We're going to be using a layer 2 VPN. Okay, so we'll just leave the VPN configuration on here for now. We can get rid of like the PIM, the multicast specific. It looks like, yeah, but we've got a type VRF, so pretty much we're just going to be converting that type and using a different kind. So we can certainly get rid of the PIM, but and then we can get rid of the VPN signaling. Unfortunately, this naming is kind of junky, but we can change the naming as well. But let's just start by getting rid of the PIM, because right now what we're using is an MVPN. So yeah. I guess if we're using an MVPN, getting rid of the PIM is going to destroy everything. So let's clear off the other side here for CE2 of PIM, and then yeah, we're gonna brick everything if we configure the delete the PIM, because we're using a multicast VPN right now. So if we disable multicast, it's not gonna work. Okay, so I don't even have a, oh, because I forgot to save the configuration. God damn it. But I can put anything I want here. So let's do a IP. Oh, never mind. I can't. I've got to have it connect up. So let's do a show in terse, type match, GE dash. Okay, so let's do a show in descriptions now. See which one goes to the host. Okay, 001 goes to the host. Okay, so let's add .2 to the host. And oops, okay, yeah, it's this one. Okay, and then we need a gateway, and that's going to be .1. All right, and now I can just do a save, and hopefully in the after work video, if I need it, hopefully I won't, it will be saved there. All right, let's do the same thing for CE1. So show int descriptions. So the host is 000 in this case. Okay, so let's put .2 on 1. Okay, so we're good to go here. Let's just give it a shot and ping end to end right now. I don't think it'll work because I removed the configuration from the CEs that allows for multicast. So I think we're going to need that, but let's just give it a shot, if I may. There we go. Oops, so it looks like it's frozen. Oh, nope, there we go. Perfect. Okay, so yep, we've got a timeout. Let's do a, let's just try it one more time because it might have been, yep, so it was just due to ARP. So yep, everything's good even though I stripped that configuration. So yep, so we've got that stripped. Let's keep stripping and let's have this going so we can see right away if something we stripped affects this. I'm curious to see what will affect that. So maybe there's a control T. Yeah, there we go. So now hopefully this just keeps going, and then as we strip the configuration and try to change it from a NVPN VPN to a EVPN, we'll see what causes this to go, and then we'll hopefully try to get that to come back with the different method. Okay, so let's tank all of the multicast stuff. Okay, and now, oops. So you can't have, of course, because it's multicast. So I would have to delete all of the MVPN related configuration, but I can do that. That's not a big deal. So let's delete this as well. I think we could just leave that in. Let's just try to commit it without that. Okay, so let's try this. Commit that. Oops, so point to multi-point LSPs can be configured only for EVPN, VPLS, or MVPN instances. So our LSP is no longer valid because we've got a point to multi-point LSP. I think I don't see it. So might need to get rid of this. Let's try it. Okay, so this looks like it's going to go through. When it thinks like that, it's usually because it's going to go through. And yep, so now we're getting timeouts. Now we've bricked the configuration here. So let's take a look at the P router. I think it will be fine. I think the PE router, the P router, the provider router, won't need any configuration if I can open that. But it looks like I'm having an issue opening the P router. Oh, and this is really interesting too. It looks like it's pinging now for some reason. So I wish I could open up the P router, but it looks like it's not obeying my commands. Okay, there we go. All right. So yep, everything looks good. The only difference, we won't need MVPN signaling anymore, but everything else is going to be the same. And of course, we can just leave the MVPN signaling there. There's no harm, no foul, but we just won't be sending that anymore. In fact, if I do a run show route, my MVPN table, I believe at this point, will be empty. Well, I just don't see an MVPN table, which I'm kind of surprised by. But let's just get rid of this line. Okay, so now let's go to the final router that we'll be modifying, at least when it comes to stripping down the MVPN. Now, one thing to remember, or one thing to keep in mind, so we removed the MVPN, but the MVPN, let's take a look at the configuration on here. So the MVPN sits within a VRF. So we're still going to have the VRF. We're just no longer going to have the MVPN, so we won't be able to use the oh, was this side missing the, oh god, that scared me. Oh man, that really scared me. Yeah, I'm just like really on edge right now for some reason. Okay, so let's see here. We've got okay, so I'm just going to erase all of this configuration like I did on the other side. Before I do that though, I will take a look at the routing table. Okay, so now we can see this is more what I was expecting to see. We've got NVPN, but we've got, we do have things in the table, which is interesting. I wasn't really expecting there to be anything there, but yeah, so I don't know what's going on. Okay, so we won't need this. Okay, hopefully that will commit. Okay, so, and I think it will still ping. Yeah, it's just going to need to change a bit, but it'll reconnect. It's just using a different kind of path now because it's just using the VRF. And a VRF is basically just a regular table. It's just a custom table. So it's basically using INET 0, but it's a differently, it's a custom INET 0. So yep, see INET.0, but it's custom. It's not the default instance of INET 0. Okay, and then it's exchanging L3 VPN routes. Okay, so let's try to configure an EVPN now that we've got everything all set. So let's go do a show configuration, pipe display set, pipe no more. Okay, and I will check that message. I'm on lunch break, but I just want to see how, because I told them I was going on lunch, so I just want to see if they're cool with that. Oh, okay. Okay. Yeah, they're cool. Perfect. Okay, everything's going to be just fine. I can just focus on this, and then when I get back, everything will be ready for me to go. Okay, that makes me feel a lot better. Okay, so let's, yeah, so everything looks pretty good now. It went over the routing table change. I guess I should have done a better before and after, even with a comparison. I'll try to do that from now on. In fact, let me just do that. So I've got the routing table here. So we're going to save a copy of it. Yep. And we're going to save it in Notepad++. And then we'll do a compare on it after we set it up for EVPN. Okay, so show, oops, come on, show, oops. Okay, so let's see how we can set it up for EVPN. I have a feeling we might need to add a new family. So let's see what families are available. Okay, so we've got L2 VPN options here. So let's see signaling. So I have a feeling we might need that. One thing I would like to do is change the name of this group just because it might be confusing. So let's do an edit and then show type display set relative. Okay, and now let's do an up and let's do edit group. We'll do group dash EVPN. Okay, and then we'll have all the same configuration, but it might need to change eventually. Okay, so now let's do a show pipe compare. All right, so now we've got it changed, so it's no longer going to be confusing. Oops, so may not be configured. Oh, so I forgot to delete this one. So delete protocols, BGP, yep, and then group there. Okay, so now show pipe compare. So perfect, okay. Okay, so we just changed the naming of that BGP group. Let's do that same thing on PE1. So it's simpler. We might need to do it on the P router too. I'll check that after this. So yeah, I just want to make sure I didn't have any configuration left over. Let's do a edit protocols, BGP group, and VPN, show pipe display set relative. Okay, so now on up, edit group EVPN. Okay, and then we'll add all this there. Perfect. And now an up, and we'll do delete group MVPN. Show pipe compare. Perfect. All right, so now we've got those named correctly. Let's just do a quick check on the P router to make sure that there aren't any confusing names on there. Okay, so oh, yep, it's MVPN on there as well. So let's fix that. Let's do a show pipe compare first. Make sure there's nothing queued up. Okay, so we're good to go. We've got the naming. Makes more sense. It really doesn't matter on the P router, and then of course it doesn't matter on these either. But I just don't want to have it be confusing. Okay, so we've got everything good to go. So let's go and see what kind of instance types we can have. So we can change it to EVPN. Let's try just straight up changing it and commit. And hopefully it will guide us to see what kind of configuration we need to complete this. So protocol EVPN must be configured in the EVPN instance. So let's do edit, or yeah, edit routing instances VPN-A, show pipe display set relative. So this currently is not an EVPN instance somehow. I don't know why it's not an EVPN instance. I would like to make it an EVPN instance. So let's just do a delete. And then let's just start with set instance type EVPN. And then we'll add the interfaces to it. Set interface 001.0. I think we can have a route distinguisher. But let's just start with this. Okay, so interface type EVPN. Protocol EVPN must be configured in the EVPN instance. Oh, okay, so I actually know what they're talking about now. So let's do instances VPN-A. So let me do a rollback 0 actually, because I think the configuration that's on there already will be useful. Okay, so let's do a because they want a what do they even want? They want something. So they want EVPN protocol enabled. So let's do set protocols, and there we have it, EVPN. Okay, so now let's see if this is all that's needed. Perfect. So we converted it to a EVPN via EVPN VPN. It used to be a NVPN. Then we actually converted it to just a straight up VPN, layer 3 VPN. So, but now it is, oops, so this is interesting. Let's try changing the instance type to EVPN. Okay, so loopbacks are not supported under EVPN instances. So let's get rid of that. Okay, and now VPLS encapsulation should be set. So let's set some VPLS encapsulation on this. Okay, now let's see if this commits. Oops, so multiple loopback interfaces not permitted in the master interface. Now that we took .1 out of a different routing instance, there's now 2 loopback interfaces in the master routing instance. All right, so let's get rid of that. So delete interfaces LO0. Let's see here, show int LO0.1. All right, so we can just delete that. That's for the, I think that was the rendezvous point for multicast. So we can just get rid of that. Okay, so let's try to commit again and then deal with the message that shows up. So protocols OSPF, not allowed under an EVPN instance. That makes sense. If it's Ethernet VPN, it's layer 2. So having a layer 3 protocol makes a lot of sense. Let's do routing, edit routing instances, VPN-A, show pipe display set relative, and we'll delete protocols OSPF. Okay, so now we've just got this one. VPLS encapsulation should be set for adding VPLS routing instance. Okay, so let's do edit interfaces, GE001, show pipe display set relative. So I do have it set. I wonder if they want it to be set beforehand. Okay, so I think what I'm going to do is delete this line, then try to commit. And if it commits, which, oops, so family VPLS not valid on this interface. Okay. And I believe that's because family iNet is on there. So let's try getting rid of that. I'm kind of worried it won't. Well, let's get rid of that. Okay, so now we've got no more family iNet here to CE2, and this makes sense because basically what we're trying to do before we had CE2 connect up to PE2 using a routing protocol OSPF, but now we're going to treat this as if it's just one long wire from CE1 to CE2. So we won't even need OSPF on CE2 anymore. It's just going to do layer 2 all the way over to CE1. It'll be seamless, as if it was just one long wire. That's the point of having a layer 2 VPN like this. So let's see here. Let's try to commit that. Oops, so it's still not valid on that interface. All right, so I mean, let's try deleting unit 0. Oops, up, delete unit 0. Now let's do set family VPLS. Let's do set encapsulation. Yeah, and then we're just going to set the encapsulation to VLAN VPLS, and now we'll edit unit 0, and we'll set family VPLS. Okay, and now we'll do top commit, and that will commit. Oh. Let's do Ethernet VPLS, not VLAN VPLS. Okay, so this is really good news. It just says that we're missing our final step here. Display set So it'll be adding that interface here. And I believe it was, yep. Excellent. So it is now set up for EVPN. So let's do the same thing on PE1. Got another 15 minutes here. Okay, so of course we're not going to need layer 3 protocols anymore because this is a seamless layer 2 service. So the customer basically just experiences just a regular old wire from one of their devices to the other. Okay, so now we're also going to no longer need this. Come on, there you go, perfect. And then we're no longer going to need, okay, so it's the one facing the customer. So yep, we're no longer going to need all the configuration on here. It's got to be changed. Okay, so now it's going to be set, encapsulation, Ethernet, VPLS, set, 0 family, VPLS. And now we're going to be changing the instance type. EVPN. Now we got to enable protocols. EVPN. Okay, and I think that's everything we'll be able to tell. Perfect, so that's everything. Let's see if our end-to-end ping is still going. Okay, so it looks like it's switching. For a while, it definitely was not going. But it's switching over. We should have a seamless connection. Looks promising. Looks like it's just thinking about switching over. So it's getting a reply from 10.10.12.1. Let's figure out what that is. Oh, so don't have it here. So I think that's on the CE, and that makes sense because we're not going to be having IP addresses anymore on these PEs. We're going to be dealing with, and I will show you. Yep, these 304 MAC. So we got MAC addresses being sent with our special information. So it looks like this is good to go. I'm curious why it's not working on the CEs. Maybe there's some configuration I missed on there. Let's take a look. Okay, so we're no longer going to need our we actually might need our OSPF configuration still, but our neighborship is going to be formed with the other CE now. I'm actually not sure. We will need a OSPF neighborship with the other CE because if we just think of it as one long wire, CE1 still needs to learn about this network somehow. So let's do a show OSPF neighbors. Oh, so we are going to need a neighborship. So let's figure out why we don't have one. Let's open up the other CE because it looks like the EVPN is fine. So I think the CE configurations need some work. And in fact, I think I know exactly what the problem is. So these are no longer to PE1 because PE1 is just a seamless connection now. So let's change that description. Okay, so the proper position description is this is now to C2 because it's just a dumb seamless wire connecting the two now. So your customer has a better experience now because they don't got to deal with the ISP. The ISP is just completely behind the cloud. Okay, so it looks like I didn't even clean this one up very well. Let's do that first. Okay, and then it is still going to need the OSPF configurations, but I'll show you what the problem is in a second here after I change the description here, because it's now going to be going to CE1. Okay, so now we've got our descriptions correct, and we've got things ready to go. But let's think about this being just a plain dumb wire. So what does that say about these interfaces? Well, if this is all one broadcast domain now, these need to be in the same subnet. So let's try that. I think that'll work. So let's go configure private, show interfaces GE000. Okay, so this is to CE1. Let's take a look at the other one. Oops, I don't think I committed the change yet, so I will do that. And of course, this is going to be 1 instead of 0. Jesus. There's some birds out there trying to smash in my window or something. Yep, so you can see obviously it's not going to work because these are now in different subnets, and it's now as if they have a wire directly from one device to the other, so they've got to be in the same subnet. Okay, so let's change the IP addressing. So we'll do edit int 001.0 family inet delete address. Oh, I gotta specify the address to delete. We'll delete that one. Set address, and we'll go with 10.0.99.1/30. Okay, top commit, and then we'll come here and do edit interfaces 000.0 family inet delete. Okay, and we'll do set address 10.0.99.2/30. Okay, so now hopefully those pings will come back. All right, nothing yet, but there's plenty of things we can do to troubleshoot. Let's start just by pinging from one side to the other. Okay, so here's our problem right there. Okay, so obviously there's something wrong with the EVPN configuration. Yeah, and there aren't even any hops anymore since it's all transparent behind a EVPN. So yeah, I think the problem is that well, I don't know what the problem is. Maybe because there's, let's see here. Well, let's see if there's a OSPF neighborship now. There is not. All right, so there must be more required for this EVPN configuration. Let's do a help apropos EVPN. Okay, so we don't have any information. Let's just do this help apropos, and we'll do a pipe exclude pipe except anything that begins with a space. So this will, I think, give us some insight into what is needed. Yeah, let's say show Ethernet switching, show L2 learning. How about show EVPN statistics? Okay, so not a lot of help here. Let's do show EVPN instance. Ah, there we go. So now we do have an instance of a VPN and it is up. Let's take a look at the database. So we do have a database. Everything looks decent on the EVPN, so I'm not sure what's going on. Let's do a show route protocol EVPN. So yeah, everything looks good. I can't think of what else needs to be looked at. All right, so yeah, everything seems fine. It's really not kind of giving me a lot to go by here. So yeah, I'm not sure why it's unable to work. Oh, and I've got about 5 minutes. Okay, so here's the MAC address table for EVPN. So I am learning on PE2, I am learning something across PE1. It looks like I'm not learning anything for PE because this port goes to CE2. So I would think I would need to learn something across 000 as well. Yeah, so I think I'm not learning enough Um, that's not even a valid command. Help is not very helpful, I will tell you that, at least now on the Juniper CLI. You know what? I might need to add another port to it, because my core ports have IP addresses. Yeah, I think that's the issue. My core ports are configured incorrectly. Well, I don't know, because they're MPLS. Let's take a look at this some more. I mean, this doesn't look right. Well, that's it for this video. Thanks for watching. We'll see you in the next one. Yep, gotta get back to work.